Today we're going to show you how to make this keychain bottle opener on the Bantam Tools desktop PCB milling machine using 3 basic toolpaths in Fusion 360. If you're new to CNC and are eager to get started using CAM, this video is for you. One note, to show off this demo, we'll be using machining wax. It's a great material to test a design with, and more importantly, test toolpaths, as in this is a good material to prototype with, especially for beginners. Let's start by opening our design in Fusion 360 and navigating to the Manufacture tab. CAM can be broken down into 2 main buckets, the setup and the toolpath programming. In the first step, we'll need to tell the software 3 things: how big our stock is, how our stock is oriented in the machine, and how our model is oriented in the stock. It's a lot of orientation, but it sounds more complicated than it is. Setup, new setup, enter our stock size. Now we'll position our model in the stock using the model window. And lastly, we'll update the model orientation by choosing the box point that relates to the top side, front left edge of our material. Okay, setup complete. Now let's jump over to adding our toolpaths. The first cutting strategy we'll use is our facing toolpath. By default, this will remove material from the top of our stock down to the top of our model. For all of the toolpaths, we'll need to enter 5 important cutting parameters, which relate to spindle speed, cutting feed rate, plunge rate, and the amount the tool steps over and down in each consecutive pass. Let's add those into our facing pass. Select 2D facing, choose our 1/8 inch end mill, and now 3 of those 5 parameters in the first pane. When milling wax in our machine with this tool, the RPM should be 22,500, a cutting feed rate at 80 inches a minute, and a plunge rate of 20 inches a minute. Stay with me, almost done. Navigate to the Passes tab, and we'll want to step over at 50 thousandths of an inch and then down at roughly 100 thousandths of an inch. Click OK, and now we have our facing pass. All of these numbers can also be found on our website. Now comes the fun one, the adaptive toolpath. This toolpath will rough out the bulk of our material in the most efficient way possible using an HSM strategy or high-speed machining, and will create toolpaths that avoid sharp 90-degree turns. We'll use the same end mill and speeds and feeds, and then again navigate to the Passes tab and enter our step over and step down. In adaptive, the optimal load is essentially step over, and maximum roughing step down is our step down. Lastly, rather than machining away all of this material, let's only remove as much as we need. Remember, efficiency. Click the Geometry tab and we'll create a machining boundary 1/4 inch outside of our outer contour, and generate. To keep things simple, you can also use an adaptive toolpath to mill out the whole of this keychain. However, there are many specialized toolpaths in Fusion, and as you get your feet wet, you'll discover a boring operation is better suited to this. Now let's clean up the outer edges of our part using a 2D contour pass. This toolpath will follow a single contour that we select. Here we'll remove only the material left on the walls from the previous operation. We can keep all of our speeds and feeds the same, and again navigate to our Passes tab and enter in our step down number. You'll notice our inner wall still has a stepped look to it as opposed to a smooth face. This is due to the geometry of our flat end mill. For our last step, we'll rely on another contour pass, but this time a 3D contour pass. Here we'll use a smaller ball end mill to create a smoothed angled surface. Let's add the speeds and feeds from our site, and we'll restrict the machining boundary to just this slope by selecting 2 edges. Okay, let's see this all in action. There are obviously a lot more options to customize cutting strategies in Fusion 360. It's a deep tool, but hopefully this gives you an overview for 3 important CAM strategies that you'll need to master as you begin making precise and reliable parts on the Bantam Tools desktop PCB milling machine. And hey, if this is your first rodeo, definitely pick up some machining wax, and remember that you'll need to adjust the speeds and feeds that you use for every different end mill and material that you're milling. Okay, happy milling. CAM on, carry on, CAM on.